Welcome back. Let's go ahead and delve into this chapter. So the chapter we're looking at is chapter 22.2, Britain led the rise of industry. We have already looked at factors that led to industry that Great Britain had at the time. And so then the question is to continue our analysis of Britain and to see how did that industry happen. It starts with the agricultural revolution, but where does it go there from there? And that's what we're going to look at here. So go ahead and read that chapter and come right back. So welcome back. Let's go ahead and start looking at some of our people here. So we're going to be looking at a series of inventions that kind of are involved or tied up in the industry known as the textile industry. So where the Industrial Revolution kind of begins with agriculture, and it begins with a swelling of population, the demand and consumption of goods, and the trade and sale of surplus agricultural goods, as well as goods in the area of the textile industry. That's really the industry that kind of kicks off our Industrial Revolution in terms of manufacturing. And so we want to look at textiles and how the development of technology happens within that industry. And so what is the textile industry? Well, the textile industry is the creation and weaving and processing or whatnot of fabrics. And you can think of that as being kind of an interesting industry. But when you think about it, you realize that, okay, fabrics are there for clothing. Fabrics are there for all sorts of other things that you might find around daily living, curtains, bedding, the weaving of things like, canopies or whatever. So there's a vast demand for people, especially if you have population growing, to be clothed and to have these luxuries. And you can even think about people as they're building an income and maybe excelling through the classes and have surplus money to spend, perhaps to have more than one outfit. Maybe they've got two or three, okay, and they can afford to put, things like curtains on their windows and whatever else they need textiles for. But it's interesting, comes through with the textile industry, mainly in the processing of wool, which is that raw material you get from sheep and such. What else do they say? Flax and the weaving of flax fabrics, as well as the rise in the demand for cotton and cotton plantations and cotton weaving and whatnot, fabrics made from cotton. And so that's another factor here, because we're looking at cotton being a grown crop that's harvested, and a cotton industry that's very, very much propelling the economy of, yes, the newly founded or newly developing America, United States of America. And interestingly, a whole industry depending upon big, wealthy plantation owners, typically in the southern United States, who also use slave labor to process that cotton crop. But it's very high commodity, high demand, and we'll see how the weaving and the textile industry is influenced by the Industrial Revolution. So let's go ahead back and talk about John Kay. So John Kay is another guy who's going to be on your list of inventors. And what he invents is this thing called the flying shuttle. And it's funny because we think of flying shuttle, we probably think of like the space shuttle or some sort of airplane or whatever. But it's actually this thing, which is a piece of equipment used for weaving. I don't know if you are a weaver. I'm not an expert weaver, but as you have the lines that are running lengthwise on a weaved fabric, they're shuffling like this. And every time the machine or the loom shuffles your threads like this, in between my fingers, so like right there, will pass another thread, just like you're weaving a basket, which you probably did for like a craft back in elementary school. But this is the thing that would shoot back and forth, and you would put a bobbin or a spool of thread right here in the middle, and it would unravel as that thing shot back and forth underneath or between the threads as you lifted and lowered them. A lot of more terminology if you were an expert weaver, which I am not. But the flying shuttle as a concept is a little bit out of our realm of experience, other than if it was a piece of aircraft or something like that. But the point is that it's a technology that instead of, I don't know, however else they used to do it, when you're weaving, you kind of go in and out, in and out, in and out. Okay, this thing you could shoot back and forth, and it speeds up your weaving apparently twice as fast. So in effect, what that means is with the invention of the flying shuttle, how much faster can a weaver weave? Twice as fast. Then how much can you weave in the same amount of time as you could before? Well, twice as much. In other words, now you've doubled your production of weaving just with the development of one piece of technology. So think of that. That's revolutionary. So suddenly weavers can weave faster, and that's about 1733. Okay? So then we get into other things in the weaving and textile industry. And so we're going to look at James Hargreaves. He's another guy, and he invents the spinning jenny. The spinning jenny was a device that looked like this, and what it was is something that helped with the spinning of threads. Okay? Now, I want to ask you this question. What do you need? So if you can weave threads faster, then what do you need to produce faster if weavers are weaving faster? Well, you need to produce faster the stuff that you're weaving with, the threads or the yarns or whatever. And so how do you produce threads? Well, you spin them. Even today, you can kind of catch somebody who's taking wool and spinning it into yarn. So you kind of get this effect of that, how that might work. And this is a device that can spin more than one thread at a time. And it's just a hand cranked turn thingy. So a person is still cranking the thing, but one person can spin more than one thread at a time. And so now you've more than doubled your production of threads. So that's an important thing. You need to produce threads fast enough to keep up with the spinners. And the spinning jenny allowed that to happen by 1764. So James Hargreaves developed the spinning jenny, and then we see versions that improve this over time. One of the other guys is Richard Arkwright, and Richard Arkwright invented the water frame. And so the water frame took water power and basically spun threads using water power. So now it's all mechanical and non-human powered. So whereas before it would be cranked by human power, now it's actually just water power powering the spinning of threads. Now, what's that mean? That means that you don't have to have a human shift or expel human energy to create this product. You can use the constant flow of a river and harness that energy. And now you end up with this sort of idea that the production of thread can be continuous, okay, 24/7, as long as that river is running and you're harnessing that energy to propel your machinery. It can run all the time now. Okay, so that's also something revolutionary there. So 1769, a couple years after the spinning jenny, somebody's like, hey, let's attach that to a river. Okay, we have Samuel Crompton, who in 1779, so again, a couple years later, develops the spinning mule, as it was called. A mule was a workhorse, wasn't actually literally a horse, but a animal that would be driven to do lots of work and be up to that task. Well, the spinning mule wasn't driven by mules, but it combined the effects of the water frame to spin finer and stronger threads. So it was a further development in that technology to make a better product of spinning finer threads. So at this point in time, you actually have the spinners overproducing their product of the threads and whatever. So they can actually produce threads at this point faster than the weavers can weave it. And weavers are still using looms that are mechanical and human driven with the flying shuttle, shooting back and forth. But we now have a deep need for Edmund Cartwright, who comes in and invents the power loom. And the power loom, as you might guess, is a loom that is mechanically run by some outside energy source. In this case, let's presume it's water power. But, in time, you could attach this thing to any other motor or energy source, be it electricity or coal, as we will talk about in future slides. But at this point, in 1785, which is 200 years before I was born, we have the invention of the power loom, which is a weaving machine that is mechanical. So now you have a weaving machine that the human interaction with it is maintaining and repairing it, and of course building it, but then just loading the spools with threads. The spools, loading them up and fitting them and whatever. But then you just let the machine run its course. So again, a revolutionary thing in that textiles are now being manufactured consistently using water power, in this case, with the power loom. Okay, now I like where we're going here, because you have, economically, you have overproduction of, you have underproduction of threads as stimulated by faster weaving, created a demand for a faster way of spinning threads. So suddenly you have a faster way of spinning threads that demands a faster way of weaving them into a finished product. Thus the power loom here. And then you have actually a higher demand at this point for a raw material, let's say it's cotton, because you're spinning it so fast and you're weaving it so fast and you're not pulling it off the field fast enough. And so here comes in a demand for a device to remove that tiny little seed from raw cotton. Cotton at this point, which would have hand-picked from the fields by, let's just say by slaves, largely. But you couldn't just send that product away. It was still very raw. You needed to remove all the little seed parts from the cotton fibers, whatnot. And that was a time-consuming task. Here you're sitting there pulling out the seeds by hand. So Eli Whitney, who's actually an American inventor in the cotton industry, invents the cotton gin, which allows you to throw cotton through it, and little forks or whatever, you turn your crank and little forks and whatnot will pull apart the cotton, remove the seed, and give you a nice, clean, finished raw product that can that quickly removes that seed from it, so it can go faster than to spinning, right into spinning. Now you can see that this is an early one, hand cranked. It wouldn't take nothing for this to be mechanized and set to water power or something like that. So 1793 of the cotton gin, and thus completes the chain of the rise and speed of manufacturing production in the textile industry. And the textile industry workhorse in terms of the country overproducing textiles to the global market right now is Great Britain, is the country of Britain. And they're producing so much they're able to sell then to other countries. And you can see how this is revolutionary economically for a country that has the stability and all those advantages we talked about last chapter, to be industrial and really to have a head start in developing these inventions and factories and industry for the manufacture of these goods, in this case textiles, which would be profitable for Britain. Britain has then an advantage over any other country because every other country is producing stuff differently. So let's take a look and see what the old way was versus the changing new way in Great Britain in terms of lifestyle. Now, this was a very brief segment of your chapter, but I think there's a huge worthwhileness in looking at the shift in lifestyle that occurs and the transition between what we'll call the domestic system into the factory system. So let's talk about that a little bit. You'll see actually this picture right in your textbook, and this one's depicting work done in a factory setting, and you can see the bobbins or whatever, the spools of thread being loaded up into these weaving machines, and all of them being like belt driven off these shafts running across the ceiling, which is very different than this domestic system. And domestic means home, in your home, in your domicile, your home unit, where the homemaker or the people in the home are spinning right at home. So we'll talk about the shift in systems. So let's take a look. So what happens with the Industrial Revolution and the textile industry in Great Britain is the moving from the creation or production of spinning and weaving from the homes of people into factories. Okay. In the domestic system, to simplify it, what you had, so you have a local global demand for textiles. Well, how do you produce those? Well, it wasn't in factories. It was kind of like the side business of homeowners. They would spin on the side or whatever and create threads, yarns, whatnot. And another home might go and take that yarn, that raw material, and weave it, kind of, if they had that equipment. So the point is that work was done at home by the people living in the homes. You have hundreds of thousands of homes across the countryside, and they're all contributing a little bit to the manufacture of textiles. Now, the problem with this is that it's very inefficient. It's slower. The productivity was less. But the nice thing about it was the domestic system was that the people themselves controlled the pace, the quantity, the rate at which they did this, and in balance with their own lives and what they were doing with their own lives. Okay. Now, especially women, because women would typically be up to this task of being in the domestic system of weaving and of spinning threads, whatnot, and also keeping house and upbringing of children and whatnot. So they could balance all of that sort of lifestyle, that traditional home lifestyle, with the work that they did, and they contributed their product to the market, but just from the home. Okay. Now, this is an example of textiles, but this could also be said true of, things, any sort of product that now we see mass produced. Back in time, you go back, a lot of those things might be a highly skilled trade that was done kind of at the home or at the home shop of somebody, whether it was tanning or whether it was leather work or whatever. Okay. But in any case, what happens is that there's a shift then when you can realize that, hey, if we build a factory and bring the employees to us, allow this machinery to be, produced by water power, we locate the factory by a river or whatever, and we bring the employees to us, then it changes, because no longer are these people living and working out of their homes at their own pace, but they are brought into a place of employment, a bigger center where things are more efficient, yes, but the person is there for their shift, completing their work. So let's take a look and see what that looks like. Yes, the factory system increases the efficiency and productivity and pace of people, therefore creating more product in less time. However, it was on a rigid shift schedule, so people no longer had control of the pace of their work or their lives or balancing other things in their life. They had a shift and they went there and they worked it. Okay. Another problem is that it brings people out of a rural setting and condenses them into what would sprawl out around these factories, namely urban centers or cities. So now you have people coming together for the purpose of employment, working in these factories or whatever, and basically creating urban settings, which is a relatively new experience on the scale that we're seeing it in the Industrial Revolution. Okay, the factory system also interferes or impacts the role of women in their traditional household roles. Okay, because if you're women, or if the women are now taking on jobs in a shift, which traditionally they wouldn't have had before, then those home traditional kind of roles would be displaced by the factory system. So that's now upsetting a very fundamental traditional role of women themselves in the home. Okay. Now, I know that that's a whole issue of women equality and women in the workplace today, but think about the drastic change when very suddenly you take the role of women, for instance. Now, this also goes for men because they change their role too from agricultural and kind of the hard laborious work to factory work. But imagine that, overnight, within a generation, you suddenly have a completely different role, or a displaced role that you had been living for centuries. So that kind of does play a factor here. So keep that in mind, especially with the raising of children, because now you wonder, okay, if mom is at work all day, then where are the kids? And I want to point out that some of you might be thinking, oh, the option would then just be not to work. Well, no, the option wasn't there to not work, because in the case of a two-parent household, let's say, most often, let's say, now, by the way, who were those people? Well, a lot of them were displaced farmers whose land had been bought out, and they were displaced and not needed in the farming industry anymore. So they moved to the cities, and now they are forced, both of them compelled to work, as we'll talk about in future chapters here. So they have to work. So now this changes the way kids are raised, and the childhood experience of kids themselves. So it is a big shuffle in way of life, just in society, a social shuffle, that's a shift, as it says up here, a shift in lifestyle, which is fairly drastic. And think about the impact that would be within a generation of people, have your life changed and turn around so quickly, so fast. Okay. Now let's talk about kids, because the factory system also had a place for kids. Kids would join the workforce as well when they could, when they had a role, when they could be of use, and under the is kind of taken for granted, because we might think, oh, child labor, it's so bad, they shouldn't have had to work in factories. Okay, well, we see it today too, especially in our environment. Okay, a farming family will depend upon, as soon as the kid is old enough to take on roles to help with the family farm, okay, will typically be given those responsibilities. All right, so we see that even today. Now, under the domestic system, the whole family played a part in the provision for the family. And if it was a rural household, and you're have a small farm and you're subsistence farming and whatnot, and weaving and whatnot, spinning, okay, in the domestic system, the kids also have roles. So it'd be like, okay, you're old enough to scoot around the wheelbarrow, then that's what you do. Or you're old enough to plow the field, then that's what you do. So kids were expected to have roles under the domestic system. The difference was the pace of the seasons, all these things, as well as the fact that you're kind of under the guidance of your and direction of your parents, and also the fact that you get to control the balance of your life. But kids did work here. I mean, we see that today on farms. We don't call it child labor, but some people like to. But in the factory system, it's kind of that same expectation. Oh, you're a kid, then you can help out with the family need. And if that means you going to work, then so be it. But there's harms here then for kids, because now they have to, they're not overseen by the care of their parents. They're overseen by probably somebody who cares a little bit less. They have to work constant shifts in very dangerous conditions, and so on and so forth. Okay, a lot more on this in a future chapter, but I want to show you the shift between the domestic system and the way things were produced before, food and textiles and other goods, to the factory system, which in essence brings people closer together in urban centers. It makes them depend upon shift work, where they are working way out of their own control, under the exploitation largely of factory owners. So a life of independence, a life of kind of labor, and all sorts of other misfortunes. Okay, you could probably figure out which one I prefer. Not to say that we don't depend on this today. The way we live today depends completely on the manufacture and supply of goods, largely through factories and factory workers. So, we can't say we don't need that today. We kind of depend upon the manufacture of anything that we have, depends on the factory system today. And we can see that there are very few people living the domestic system that have complete self-sufficiency, and even provide a product for the market. our world doesn't operate this way anymore. And we might ask, well, why? Well, because of the Industrial Revolution. So we have a few more points to look at in this chapter, and the next is energy sources. So we want to look and see what could possibly happen here beyond this point to propel industry forward even more. And the answer to that is the sources of energy that you have to run your factories. Thomas Newcomen is credited in 1712, so quite early on, with developing a version of the Newcomen engine. I always like to have this little animation here. It shows you this flow of valves opening and closing. Okay, what you have is a boiler here pressurizing steam, which when this valve opens lets it into there and pushes this up. Okay, and then you have this water that condenses it, cools it down, and then it kind of doesn't compress, whatever the opposite compresses, to pull that back down. And thus you have kind of a primitive form of a steam engine. And I might ask, well, what do you think this looks like? And some people will say, oh, that kind of looks like a pump jack. Well, it kind of does. You got your pivot point there and your source of energy that's pulling this side up and down. So what do you think this was used for? This Newcomen engine? You're right. I don't know if you're right. I hope you answered me. It's used as a pump, a steam-driven pump. And the reason why it was so revolutionary and important is because it allowed for a source of energy that wasn't human or animal powered to pump water from mines. So now you have another whole industry that is opening up, and that is the industry of mining. You can mine deeper, and you can pump water out of shafts. And presumably, at this point, if you can pump water, then eventually you can do things like pump air and stuff like that. So this helps with the mining industry. And we already looked and saw that mining was really important because it was one of those factors, those natural resources factors that led to Britain's growth. Why? Because they could mine and produce coal. And why is coal important? Because coal was used to burn to create energy for this device, which would evolve into what we're going to see on the next slide. And then, of course, iron ore, as we see as industry takes on, even more so, is the production of iron and metals for the manufacture of industry goods like railways and such, okay? Or technologies and construction materials like beams and whatever, the age of steel, things like the Eiffel Tower and whatever that are constructed, this new style of iron construction and whatnot, versus, brick and stone and whatever, wood, of course. So mining is really important, whether it is minerals or energy sources like coal, which is why in about 1765, you have the development of the Watt steam engine by James Watt. And yes, this is the same watt that is a measure of energy today. When we say watts, or that light bulb's 40 watts, okay, the measure of energy, because the steam engine created by Watt, or James Watt, was a source of energy, and it had a kind of a measure of power that it was able to do based on burning and boiling water and using steam pressure and steam power to turn and create, rotational power with a device that a lateral piston, okay, transformed through this arm to spin a wheel, which would spin a shaft just like a water wheel would in a river to run your factories and whatnot, okay? Much like when you pedal your bike, okay, you're turning lateral force into a rotational circular one. There I go. I'm not a physics teacher, but gives you an idea. So anyways, we have James Watt and his partner Matthew Boulton developing the Watt steam engine and actually taking and perfecting it model after version after version after version over the course of his life. The Watt steam engine becoming kind of the revolutionary thing that begins to drive the Industrial Revolution, because it's an energy source now that can be taken anywhere. long as you have a supply of coal and a supply of water, and by the way, this is a stationary thing. It's set in a plant or in a building, and you feed it, and it makes rotational power. It doesn't move or anything like that. It's set here just to create that rotational power. And it can then 24/7, rely on very little manpower because the guy is just monitoring the equipment and shoveling in coal or whatever. Create a dependent source of power away from a river. So at this point, after 1765 and the reliability gained by using the steam engine, okay, you're now reducing your dependency upon rivers to be the source of your power, for water power. And that means that factories can spring up anywhere. Well, not anywhere where there's an efficient energy source and population and whatnot. I mean, you'd have to be strategic where you want to put it, but you're not limited by needing a river to dam up and use its water power. You can now put it anywhere. It can run 24/7, dry season, rainy season, whatever. Okay, winter, summer, watt steam engine. Now, we'll wrap it up there because we're going to get into our review, but we kind of bring this chapter takes us through the textile industry, and then it gets into kind of the energy development and use of energy source kind of section of the Industrial Revolution. Now, this will take us to another evolution that happens during the Industrial Revolution. Once you have an energy source and a fuel to power it, what do you think would happen next? So we'll leave it at that. You can go ahead and take a look at your section review. The questions have been laid out for you, and we'll come back in just a minute and review them once you have given it a shot yourself. See you in a second. Let's take a look then at our section review. I think we only have 3 questions here, questions 1, 2, and 3. So we'll look at those. So the first question is, what British industry did the first inventions of the Industrial Revolution affect? Now, if you're clever, you might say, the seed drill or something. We'll separate the idea of the agricultural revolution from the Industrial Revolution. We needed the agricultural revolution to happen, kind of like set that in its own box. In terms of industry, though, the industry that was first affected was the textile industry, the weaving and production of fabrics and that type of stuff. Now, why were merchants in this industry looking for ways to speed up production? Why do you think? Well, to keep up with the great demand, because you have a rising population base in the world throughout Europe, which has a demand then for a greater production of textiles to provide them with, let's say, clothe them, but of course for more things than just clothing. Also, because the merchant class is looking to profit for itself, and this is a very profitable industry to get into. So you speed up production, you increase your profits. So keep that in mind too. If you answered on the lines of to make a profit, that's kind of a common sense answer for sure. So 2A asks, name the 6 inventions that transformed the cotton industry. Let's see if I can do this. Okay, first one, flying shuttle. Second one, the spinning jenny. The third one was the not the spinning mule, but the water frame, then the spinning mule, then the cotton gin, then the water frame. No. Let's just put it up. Power loom. There you go. Mechanical weaving, the loom, and then the cotton gin. So these are your 6 inventions that transformed the cotton industry or the textile industry, because we could be weaving through the same technologies, like I said, flax fibers as well as wool. But cotton actually really becomes, because of its superiority, the product of choice. Now, if you could do this quickly and make a really good product that outdoes the product made by the domestic system that in factories, then you have accomplished it well. And I think that all these inventions build off each another to make a better product in the end, that you finally have kind of an industry that shows the evolution of industrialization happening, by making machine-powered things that do what humans could do. And that's really also another factor of industrialization, is machines that do human things. Now, the next question is, how did each of these inventions lead to another? And in a nutshell, it says, with the invention of the flying shuttle, spinners could not keep up with weavers. The spinning jenny solved that problem, because spinners could spin faster now. The water frame added power to drive the spinning wheels, and features of both were combined to form the spinning mule. And all that means to say that spinning becomes mechanical, non-human powered, other energy sources, and reliable, spinning multiple things faster and creating a better product. And then creating a demand for the cotton or the raw material. The cotton gin increased production of raw cotton for factories, so you could spin even faster. And finally, the power loom was developed to speed up weaving and use mechanical water power or steam power later on to power looms in factories to create mass production of textiles, cotton fabrics. Okay. I want to point out that I have a few videos that show weaving in this industry of textile, which I'll pop up toward the end of the video here, and include a look at the the flying shuttle, as well as weaving or a power loom as we see them today, because our factories are pumping out textiles even to this day. Okay, the clothes that we're wearing that are woven by threads. Now today you don't just have, like, if you have full 100% cotton clothing, it's pretty fancy. I think that it's kind of been overtaken by polyester type materials and synthetic threads and that type of thing, or a blend of them. So a lot of different things in our technology today, but it's still an important kind of critical industry to create fabrics, to weave fabrics. The clothing industry itself, I mean, we would all die. Nobody would be able to live in Canada ever if it wasn't for power looms that we see today. I mean, unless you are wearing furs like our good First Nations were. Alrighty. Number 3, what drawback did early power looms and spinning machines have? And the drawback they had is, you might say, they couldn't do it as good as humans. Well, in time they sure could, and they could do it faster and better and create more. The drawback they had was they ran on power and depended on location to be near a stream. Now, how did the invention of the steam engine solve this problem? Is that it allows a factory to be located anywhere. Steam as a source of power could be used anytime and anywhere, as long as you had a supply of water and coal or wood or whatever you're using to make the steam. Okay, that wraps it up here. I'm going to pop up a couple videos before I conclude, and we'll check them out, give you an idea of the textile industry. Don't forget about this drastic change that happens in society as we transition from the domestic system to the factory system, which is sort of to say an idea where the majority of human beings lived in rural agricultural settings, and that transition to the majority of human beings living in an urban populated setting. And that's a huge shift when more of your population is taking on a different sort of lifestyle in an urban center. More on that later, but let's get into a couple videos.
Fabric is made from thousands of braided threads. This mill has 700 bobbins of polyester. Each bobbin contains 250,000 meters of thread. We begin by separating the threads. This warp unit takes the 700 strands and assembles them. Then this comb separates them. Other strands are added, and in total, there will be 7,000 of them well aligned. One fabric is composed of threads braided at 90 degrees. The warp threads are assembled lengthwise, while the weft threads are joined transversely. To prevent the threads from tearing, they pass through a bin of glue. These rollers eliminate the surplus. The glue will be removed with water before dyeing the threads. The glued together threads exit this machine. These large green cylinders are heated and dry the glue on the threads. Knitting will soon begin. The 700 strands are newly separated on this loom roller. Each thread must pass through a blade to produce a specific design. This machine takes the 7,000 strands of thread one by one, and they pass through the blade. It's a highly precise operation. The threads pass through a blade, and the weaving finally begins. On this jacker-type loom roller, the warp thread is inserted by a jet of air. The weaving machine assembles 2 loom rollers made of 7,000 strands. The fabric reaches a width of 3.65 meters. The dart threads are inserted into the weave. They insert 600 weft strands per minute. The blades remove the weft strands to insert the warp ones between the two. A comb pushes the weft. The plate of the breakage chain stops the machine should a thread break. This bobbin contains 250,000 meters of thread. That's 250 kilometers. The weft thread is in the insertion nozzle. When a weft is inserted, an air jet nudges it in. The loom roller operates at full tilt. It makes 600 thread intersections a minute. Weaving is now over. We move on to the following steps: washing and dyeing. Washing is done in a soapy solution at 80 degrees in a continuous manner at a speed of 60 meters of fabric a minute. The fabric is rinsed in clear water of about 30 degrees. Now it's on to dyeing. This is done with jets. Up to 12,000 meters of fabric are placed in clean water into which colorants have been added. The solution is heated and the fabric soaks here for about 6 hours. Then it will be rinsed in lukewarm water. The fabric is placed in a bin. This machine is called an opener. It unfolds and stretches the material before rolling it up on an immense roller. And now the roll is almost full. We now move to thermosetting in a high-temperature oven which dries the fabric. The temperature is 200 degrees centigrade at the oven's entrance. The fabric circulates here for 45 seconds. This finished roll weighs 1,500 kilos. The bobbin that we saw at the beginning has produced 25 kilometers of fabric.
Hope you like those, and let's wrap it up by saying tune in next time for the next chapter. In the meantime, DBL, and don't forget to try to do your best to keep up. Hope you're able to watch these at your own pace and that you're enjoying them just fine. We'll see you next time.